Okay, I'm going to go through a few more questions, and hopefully at the end of this you kind of get a bit of a better idea of how to graph absolute value functions. So let's have a look at the next example. Example number 6. Okay, here we go. We want to sketch the graph. The first part asks us to sketch the graph of f of x is equal to absolute value of x minus 1. Now, if you notice here, that minus 1 isn't in my absolute value. So I can't just subtract that minus 1 from my numbers inside my absolute value and then take the absolute value. I need to do that minus 1 after I've taken the absolute value. So let's do a table of values again. So I've got f and x of f of x. I'm just going to go from -2 to 2. Okay, so let's sub in -2. When I substitute -2 in, I get, so f of -2 is just equal to -2, absolute value of that, minus 1. The absolute value of -2 is just 2. Subtract 1, 2 subtract 1 is 1. So the first value here is 1. Let's go along to the next one. So I've got f of -1. F of -1 is just absolute value of -1 minus 1. Absolute value of -1 is just 1 minus 1, which will give me 0. Okay, cool. Let's do the third one, f of 0, or I'm going to substitute x is equal to 0. So f of 0 is just going to be 0, absolute value of 0. It kind of looks like a lol, minus 1. Absolute value of 0 is just 0 minus 1, which is minus 1. Okay, I'm going to go to the next one, which is when x is equal to 1. F of 1 is just absolute value of 1 minus 1. And what you notice here is that, well, when I do absolute value of 1 minus 1, that's just 1 minus 1, which is the exact same value as this, which is 0. And so hopefully you'll notice that there's a pattern, and you'll notice that for x is equal to 2, that's just going to be 1 again, which is the exact same value when x was equal to -2. Okay, I'm going to erase all this out. If you need to go back, feel free to pause and go back. Okay, so I'm going to draw the graph of this first function on a Cartesian plane. I'm going to have -1, -2, 1, 2, 1, 2, -1, -2. And I'm going to plot a few points on here. So -2 is 1, -1 is 0, 0, when x is equal to 0, we've got y-intercept at -1, and when x is equal to 1, we've got x-intercept. So there we go. And we've got those 2 points there. Okay, I'm going to draw this. And so here we've got another absolute value function. It kind of looks like a V. Oh, I drew it a little bit off. Okay, so we've got y is equal to absolute value of x minus 1. That's what we've got over here. Now, if you wanted to find the two equations of the branches, well, we have to look at what's the kind of like cutoff condition. Where's the V at? For this one, we've got the cutoff condition is at x is equal to 0. So here I'm going to have absolute value of x minus 1 is just equal to, it's when x is greater than or equal to 0, or x is less than 0, which is this middle point. This is where that V happens. Oh, I'll do it in a lighter color so we can see it. That V happens along that line, which is x is equal to 0. And so my condition is going to be x is equal to is either greater than or less than 0. The equation of the line on the right-hand side, well, I'm just looking at the positive version of my absolute value, but it doesn't actually change my -1. So here this is just x minus 1 for x is greater than or equal to 0. So that's this side of my absolute value function. That's because my absolute value is just taking my absolute value of the x, is not taking the absolute value of that -1. So that -1 is not going to change. On the left-hand side though, that's going to give me, the absolute value is going to take the negative value of everything inside my absolute value. So instead of x, it's going to be -x minus 1 for x is less than 0. Okay, so that's that second side there. So those are my two branches for this equation over here. Okay, part B, we want to sketch the graph of x plus 2. Now, x plus 2 is very similar to that first example, so I'm not going to spend too much time looking into it, but we will have a look at it. So here, the part B is f of x is equal to absolute value of x plus 2. You can do a table of values for this again. X, y. I'm going to actually start it a little bit before -2, because if you notice here, you'll notice something. -4, -3, -2, -1, 0, 1. Okay, let's substitute a few values in. When you substitute x is equal to -4 into absolute value of x plus 2, you get -4 plus 2, which is -2. So the absolute value of -2 is just 2. The next one across, absolute value of -3 plus 2. -3 plus 2 is just -1. So the absolute value of -1 is just 1. When x is equal to -2, -2 plus 2, 0. Nothing happens there. -1 plus 2 gives me 1. And the absolute value of 1 is just 1. And so hopefully we can continue that pattern. So let's draw this one. So this one is, I have a x-intercept at x is equal to 2. And so, when, -2, I mean, -2. I've got a y-intercept when x is equal to 0. That's at 2. And I've got another at -4. I've got x is equal to 2 again. I'm just going to plot this. Bam, bam, bam. Bam, bam. And so there we go. Y is equal to absolute value x plus 2. If you want to have a go at figuring out what the equations of those two branches, of this branch over here and this branch over here, feel free to have a go at that for me. I'm not going to do it here.